Hello everyone, welcome to Data Structures class. In this unit, we will introduce how to implement a recursive function to produce Fibonacci sequence. Fibonacci numbers are strongly related to the golden ratio and also appear in biological settings, such as branching in the trees, the arrangement of leaves on a stem, and fruit sprouts of a pineapple. Applications of Fibonacci numbers include computer algorithms such as the Fibonacci search technique and the Fibonacci heap data structure, and graphs called Fibonacci cubes used for interconnecting parallel and distributed systems. So what is Fibonacci sequence? As shown on the screen, Fibonacci sequence is a series of numbers called Fibonacci numbers. A Fibonacci numbers is defined as f subscript n. That is the sum of the previous two Fibonacci numbers, where the first two numbers f1 and f2 in the sequence are 1. The numbers in green are Fibonacci numbers. As you can see, the first two numbers are 1. And the third number, 2, is the sum of the previous two numbers, that is 1 and 1. The fourth number, 3, is the sum of the previous two numbers, that is 1 and 2. The fifth number, 5, is the sum of previous two numbers, that is 2 and 3. As you can see, we can repeat this pattern to produce the remaining Fibonacci numbers afterward. In this example, to implement a recursive function to produce Fibonacci sequence, we create a Java class named Recursive Fib. In the main method, we request the user to enter how many Fibonacci numbers in the sequence we want to produce. That is the variable n. We implement a Java method named fib to take the variable n as its input to produce all Fibonacci numbers by calling fibn in the main method. The sample code is shown on the screen. The next step is, how do you create the recursive function fib to meet this requirement? To design a recursive function fib, the first step is that we need to prevent infinite recursion and think about first, how to make arguments getting simpler, and second, how to set up the special terminating case. To make arguments getting simpler, one potential approach is that we can reduce the argument n by 1 each time when calling the function. To set up the special terminating case, the idea is that when n gradually reduces to less than or equal to 2, the first two Fibonacci numbers f1 and f2 can be set to 1 for display. When the function returns to the previous caller, the previous two numbers should be returned to the caller, and thus we should create an array to pass two values in the return statement. When the caller receives the previous two numbers returned, we can add the previous two numbers to produce the new Fibonacci number and update the array for return. To implement the recursive function fib, we need to return an array as aforementioned. Therefore, we need to create an array named nums with 2 elements to hold the previous 2 Fibonacci numbers. At the end of the function, we return the array named num. Next, we create a conditional statement to handle terminating case and regular case. As you can see, when n is less than or equal to 2, we define the special terminating case, and the else code block defines the regular case. To handle the special terminating case, we display f1 and f2 as 1, and then take the sum of f1 and f2 to produce f3, and store f3 and f2 in the array nums for return, where the sum of the previous 2 Fibonacci numbers is always stored in the first array element. In the regular case, we call fib by passing n-1 to make argument getting simpler. Once the function call returned, we can display the Fibonacci number stored in the first array element. After display, we can take the sum of the array elements and update the array elements as explained in the special terminating case. So this is the implementation of the recursive function fib.